Good day, viewers. You are welcome to Emeritus Technology. Today we'll be showing you our boost converter. It's a microcontroller based boost converter with the full architecture, both the circuit diagram and everything embedded into one system. So now we are using a laptop for serial monitoring, and we also have an LCD screen 16 by 2. We have the boost converter itself. We also have a power pack, which is a 135 watt power pack. At the same time, we have a 200 watt load. That's the bulb coming up. Now, if you look at the output of the boost converter now, so from the input, we have a 38 volt input, and we have an output of around 37.6 volts, because the boost converter is currently deactivated. Now we need to activate the boost converter. How do we activate the boost converter? From the calibration mode using the keypad. Once we press enter, then we enter into the calibration mode. So in the calibration mode now, we have the CV voltage on the screen. So now we just need to enter. So we have the preset voltage, which is 245 volts. I can decide to leave it. Let me just leave it now. The next thing, the current. So I just need to set the current to around the 0.8 to 1 amps, because the load I have at the output is 1 amps, or is even less than 1 amps. So let me just set to around the 0.8 amps. It's 0.8 amps. Okay. So the next thing is battery voltage. So we just need to set this battery voltage. So the 100 we are seeing is that the boost converter is capable of accepting input voltage from 12 volts up the way to 100 volts to give a steady output of 245 volts. So meaning, if you need this kind of system for charging your 12 volt to 96 volt battery system, it is ideal for that system. If you also need it to power a load that requires higher voltage at the output and you have a smaller voltage at the input, this system is also ideal for that. It's ideal for electric vehicle, it's ideal for batteries to battery charging, it's ideal for so many applications, for power supplies and many more. So I just need to set from 100 volts down to 38 volts. So I need to set to 38 volts now. 38 volts, okay. 38 volts now. The next thing is the duty cycle, which is the PWM. So the PWM is at maximum already, so I just need to drop the PWM a little. Let me take it to around, let's say 225, which should give me around 90%. Okay. The next thing is the cutoff voltage. So the cutoff voltage is the low battery disconnect voltage. So I just need to, since this power pack is 38 volts, so let me just set it to around, let's say 36 volts or 34 volts. Okay, it's fine. So trickle charging voltage. So that is when you put a load on the output and the load drops the output below a significant point, then the trickle charging will be pumped in again in order to bring out the output to the standard voltage. Let me leave it on to 40 volts since I already set the CV voltage to 245. So charge start voltage, that is when the system shuts down on low battery and is trying to reconnect, so it will only reconnect at a voltage that is higher than the shutdown voltage. So we already set that to around 34. Let me leave this on 36 volts. Okay. So the next thing we need to do, if I should press home page, then every settings I've done will not be affected, but if I should set save and exit, then it will save and exit and start from there. So if you look at the serial monitoring now, you will observe there is no serial data coming. Why? Because we are in the calibration mode. But once you go out of the calibration mode, the system will automatically reset and starts bringing the required output. Now look at it now. So the serial is already coming, and at the same time look at the outputs now. The output of the boost converter is giving us around 90 something volts now. So it will be going higher and higher until it gets to around 200 and something volts that we set. So please, at the same time, if you haven't subscribed to our channel, please subscribe so that whenever we bring new videos relating to MPPT, relating to boost converters, relating to inverters, power electronics, microcontroller, and general electronics, so that you'll be the first person to see it. At the same time, please like and share and refer us to some of your friends and many more. So now let's keep looking at the output voltage now. So the voltage is around 156 now. So, and at the same time, whatever you have on the multimeter is also what you'll be having on the laptop, and whatever you're having on the laptop is also the same thing you'll be having on the LCD screen 16:2. At the same time, you're having the watt, the duty cycle, the output. It will also tell you the mode, whether it's on CC mode or it's on CV mode. So the system is very robust, very smart, very intelligent. It's ideal for the battery to battery charging, for electric vehicle battery charging, and many more. Very smart system. If you look at the output now, if you look at the bulb now, the bulb is bright. Look at the output, we are having 192, and the PWM is still building up. It is still building up. So it's on 194 now. So it's on 196 now, 199 now. Yeah, it's on 206 now. So it's on 210 now. And if you look at the output is still on around 212. And if you look at the input is still around 38 volts. Still on 38 volts. You could also see it on the LCD screen. You could also see it on the serial monitoring at the same time. So we are having an output of 219 now. We look at the multimeter, we'll be having 219 to 220 volts here. We're having 316 volts. Yeah, thanks for watching. God bless you.